Okay, I guess we can start. Good afternoon, everyone. Thank you for joining us for this presentation about the Eclipse infrastructure and the migration to better CI for Eclipse projects. So first of all, I know some of you, but who is a committer or project lead on Eclipse project there? Okay, half of you. So you will see what is coming for you in the coming weeks. And for the other, you will learn how we are currently scaling our infrastructure to better manage all of our projects. So just a quick recap about the current infra and the current status of CI at Eclipse. So we have about 200 Jenkins instances running. So we have more than 300 projects at Eclipse, and 200 of them have a Jenkins instance. And all of these instances run on a dozen of beefy machines. And in total, we have about 250 cores, virtual CPU for running those Jenkins instances, and 1.5 terabyte of RAM. So it can sound pretty good already, but we'll see what are the caveats with the current infra. So some of you may know, but we run everything on bare iron. So each Jenkins instance runs on one machine, on one of these 1 out of 10 machines. And so on each machine we have about 25 Jenkins instances running. And every single jobs from a Jenkins master run on this master as well. We don't run on external agents, apart from very special cases. But most, if not all, of the jobs run on the masters. So here we have only 3 machines depicted, but of course we have a dozen of them. And we have what we used to call HIPP for Hudson instance per project. Now it's HIPP because we migrated to Jenkins already, Jenkins instance per project. If we had slaves for some JIPs, each slave has its own set of executor as well. And what you can already see on this picture is that one project can basically overwhelm every other because there is no barrier between each instance. So every HIPP, every JIP on one machine sees all the resources on this machine and can basically use it. So what's good about the infra? Today, as each project has its own instance, each project can decide about the lifecycle of its Jenkins instance. It can install its own plugins. It can restart and reboot it whenever it wants. They don't need to synchronize with other projects, which used to be an issue when we started with a single shared instance for all our projects back in 20-something. 10 years ago. But of course, there are some cons from this infra. As I already said, we lack isolation between projects. So a single job can basically burn all the CPU on the machine and starve the other instances. As we are all running on the same machines, all jobs run on the same machines, we need to install the common denominator of build tools, or basically the consensus at maxima of all the build tools that are needed by all the projects. And as we try to keep all machines in sync, we have to do that on each and every big machine, which is quite time consuming and hard to do. And of course we face some conflicts sometimes. So if you want JTK 3.x and JTK 2.blah, sometimes you cannot install both of them at the same time, so it's not true for JTK, but you see what I mean. Having 2 libs at the same time on the same machine can be cumbersome sometimes. And of course, we use the hardware poorly because sometimes one machine will be heavily used because 2, 3, 5, 10 Jenkins runs at the same time, while on another machine, every project is at rest. So we could use, but it would be great if we could use the cycles on the idle machine and to provide them to the projects that are actually needing it at that moment. So to show you how we identify that the resources are actually very poorly used, here is the CPU load during the whole month of November on all the 10 machines. So it's done with a simple moving average of 60 minutes. So it's already quite well. You don't see the spikes very well on that, but you can see that most of the machines are used less than 20% of the 20% of the CPU are actually used on each and every machine. And you can see that some of them are really, really idle most of the time, while some others are more used. Also, managing a dozen of Jenkins, it's quite easy to do. You can do that by hand or write a bunch of scripts. Scale those scripts to hundreds of them is time consuming. I can tell you, we do that for quite some times, and even if we already automated a lot, it's a lot of time to spend on just managing those instances. So we want to spend our time on things that add more values to projects, like hardening the digital signature services that we already provide to the service. Create new services for publication and promotion. So today we let projects publish to Maven Central, but they have to go through OSSRH and stuff like that, and it's not that easy, and we would like to improve on that. We would like to improve the infra that we have for static analysis. We have a SonarQube instance running, but it's quite the poor guys on the side because we don't have the cycles to take care of it. And we also want to better embrace GitHub, even after the fact that Microsoft bought it. But we want to be better integrated with GitHub and to automate many stuff with GitHub. So if I sum up the goals of this migration to a new infra, of course we would like to offer best services to our projects. We want to use our hardware more efficiently, especially because we are onboarding a lot of new projects with the incoming of Jakarta EE. For instance, Glassfish, currently the build running internally at Oracle use 50 agents to just run a single build, and we need to bring that to Eclipse, and we don't have infinite resources. We already have those machines, and we'd like to use better those resources. And as I told you, we would like to spend more time on some other topics about CI. So the solution that we found out the best for the community is actually a duet solution based both on a Kubernetes cluster, actually an OpenShift cluster, OpenShift being a Kubernetes distribution by Red Hat, and cloud-based Jenkins Enterprise. So for those of you who don't know what is Jenkins Enterprise, so this is not a sales pitch, okay? This is my understanding and how I feel about Jenkins Enterprise. You have a master of Jenkins, which is called the Operation Center over there, which controls and lets you apply his operation on all your instances. So here you have all the 200 instances that we are handling at the foundation, managing at the foundation. And here we have a single instance that controls all of them. Example of operation that you can run is, I want to install this plugin on all these instances. Quite handy. I want to upgrade all these instances to the newest version with the security patch X. Very handy. And what's really nice with this, with Jenkins Enterprise, it's actually not specific to Jenkins Enterprise, it's specific to the Kubernetes plugin, is that all the jobs, so the best practice for a long time with Jenkins is not to run things on masters, but to run things on agent. But with the Kubernetes plugin, the agents are actually dynamically created, provisioned, and the jobs run out there, and the agent is killed right after the build is done. So we can pool all of our resources, all of our hardware on this side, in this cluster, and all the Jenkins instances will just ask to the cluster, I need to run a build, give me an agent. I need to run a build, give me an agent. And you don't know exactly from which agent, from which machine the agent is provisioned. It just does that transparently for you. So that's a very good way to improve our hardware usage. And we hope that we'll be able to multiply by a couple of factors the usage of our machines. Jenkins Enterprise does not get rid of the current feature of Jenkins, so we can still attach dedicated agents to the masters, the Jenkins master over here. So for instance, if you want to install your own Ubuntu stuff to link your own VM on GCP or stuff like that to your instance, you can still do that. But one thing that Jenkins Enterprise actually do is that you can add or link agents directly at the operation center level and make it available to all the sub-instances, all the managed instances. And this will be very handy to provide to all of our projects a bunch of Windows and Mac machines, because we won't have to link them to each and every instance. We'll just have to set up them at this level. The way it works is pretty simple. When one instance wants to run a Windows build, it will ask to the operation center for a lease and get the agent, and then nobody can use it anymore until the build is over, and then it releases the lease and it comes back to the pool. So this thing is outside of the Kubernetes cluster, of course. It's running on standard hardware. And the specificities of cloud-based Jenkins Enterprise is not only to run the agent in the cluster, but also everything. So all the instances and the operation centers are actually running inside the clusters. So we get much better resilience with this feature, because given how Kubernetes work, if the pod, the instance where one Jenkins is running does not reply anymore to a probe, then it will be killed and respawn somewhere else. So you will have automatic restart, which will be greatly beneficial, I guess, for most of your project. We all know that Jenkins is not perfect. It needs some restart from time to time because it accumulates stuff. It gets better and better, but still have some issues. So running inside a self-healing cluster, it will be a very great tool for us to help us provision resilient service. And it's already running. If you go to jenkins.eclipse.org/cjoke for cloud-based Jenkins Operation Center, so you will see all my tests and the startup of the new instances out there. So that's basically where you will see your Jenkins instance sometimes, very soon. So you have to go to this address and click on your instance to get your new master. And everything is created right from this interface. Oh, and one more thing that let us create, the fact that we run on Kubernetes let us give to project is that you will eventually be able to use Docker to run your build. So you won't have to rely on us to provide build tools, libraries or stuff like that. You will be able to define your own Docker file somewhere, build it on Jenkins or not, publish it to Docker Hub, for instance, and then use this Docker image to run your build. So again, it will give us a lot of free time because we won't have to be the gatekeeper for installing new version of Maven, new version of Java, stuff like that. You will do that for your project and you will deal with it because you know better which version you need. So what is the plan? So in May, we've set up the whole OpenShift and CGE, so cloud-based Jenkins Enterprise, on the foundation hardware. So everything run on-premise on some server that we've freed. Starting next week, we will start create new HIPP. So every new instances will be created on CGE, on cloud-based Jenkins Enterprise, and on this cluster. And we will also start to evaluate how to migrate existing projects, so existing HIPP, to this new infrastructure. It's quite challenging because we have a bunch of them. So we want to start with volunteers first to learn and to learn what are the caveats and how to automate the whole stuff. And after July, so after the first, we plan to ramp up quite fast, and the goal is to have everything migrating by the end of the year. Hopefully much sooner, but by the end of the year we plan to kill the current infra and to run everything on Kubernetes and Jenkins Enterprise. So what are the expected disruption for projects? Actually, not much. We don't expect much. The only thing that you will have to remember is that now we are embracing the best practices. Nothing will run on masters anymore. You won't have any executors anymore on the master. Everything will run on agents. So if you were used to dig into .jenkins path or stuff like that to try to work around some limitation, it won't be possible anymore. Everything will run on agents. Workspaces won't stay, so you won't be able to browse your workspace once the build is done because everything is executed on an agent, and this agent is killed as soon as the build is done. So if you want to keep some artifacts, remember to archive them. Oops, thank you. Remember to archive them. And one of the points is also we will limit the disruption by providing a base Docker image. So when you will do nothing, we'll provide a Docker image which will be very similar to the current environment that is running at Eclipse. So for instance, for those of you know, all of our build tools are installed in shared commons, the path, and we will create a Docker image with this path. So we don't expect a lot of disruption. One thing that won't be possible anymore is the direct access to the download server. So far, the download server, where you actually promote your builds, are NFS mounted inside each machine running Jenkins. We don't want to do that on the new cluster. It would be very cumbersome and very insecure to provide any Docker image, the ability to mount this NFS point inside any Docker image. So we will promote the usage of SFTP to build.eclipse.org to upload your stuff to download. Again, we will provide assistance for projects who are still doing that with CP, the CP command, and it won't be a big change, I guess. It's really the last step of the build, and we'll be able to find a way to batch update your builds for that. Last thing, the Docker image that we'll provide won't be SUSE Enterprise, so it won't be exactly what you have today in the build environment for your master. So you can expect some changes if you are doing some C or C++ builds relying on some path and stuff like that. But again, it's not a lot of projects currently using the Jenkins instances that are doing such builds. We have plenty of time for questions, so I'm open for any. Yeah.
One question, you mentioned the concept of the previous architecture was the hardware resource sharing. So how do you manage this now with the new one?
the cons was the usage of
hardware sharing. So if you got a job which consumes a lot of CPU or
okay, so that's one of the features of Kubernetes. Here we can define a namespace in Kubernetes and set up quotas on this namespace, and each instance will only have the permissions to create agents in this namespace. So it won't be able to create as many agents as it wants. At what point it will be, the Kubernetes will say, no, I cannot create any more agents. You have to wait for some resource to be freed.
You have one namespace per project? Or?
So that's the goal. Currently, Jenkins Enterprise does not support this scheme, but we are collaborating with CloudBees to implement this feature. Currently, everything runs in a single namespace, so we don't have currently the possibility to avoid a project to consume all the resources in the cluster, but we have good monitoring tools to identify the culprits. Yeah?
I'm not sure to understand how the new system avoids the possibility to have some agents working a lot while some are idle.
So here you can consider that the cluster is a pool, and when you ask for a new agent to to Kubernetes, it will create a pod, let's say a container, and this container has a given has some resources affected. So it has one CPU, two vCPU, and a given amount of RAM, and it cannot go above that. So that's how we'll basically limit the resource usage. We could do that. We could have done that already on the infra by using C groups to limit the resource usage of each project. But Kubernetes does that very well. Why not using it?
So it's kind of virtualization.
Yeah, sure.
How is it integrated with SonarQube?
I will repeat the question. I should have repeated the question before. How does it integrate with SonarQube? So far, not at all. SonarQube is still running on its own server, and we plan to upgrade it to a newer version actually this week. And once we've migrated everything to the new cluster, we'll see whether we install SonarQube directly in this cluster or whether we create another cluster to host this kind of services, like SonarQube, Nexus, and the signing services as well. Any other question? Yeah.
You said that we can use our own Docker images.
Yeah.
So will there be a possibility to upload the Docker images, or do I have?
So you have two possibilities. The most basic one is to reference an image which need to be available beforehand in Docker Hub. It will download it right from Docker Hub. You also have the ability to specify the Docker file right inside your build configuration. And as a first step before running the build, it will build the image and then run the build inside this image. I'm not exactly sure how it integrates with the Kubernetes plugin, because this feature to specify the Docker file is not exactly provided by the same plugin as the Kubernetes plugin, so I'm not sure that you can do that now. But you can always define a single job that does the Docker build and then run your build using this image. But we won't provide the Docker registry for now.
One question. As with Kubernetes and OpenShift, infrastructure is code. Is this architecture available as an open source project?
No.
Will be?
So the question is the configuration for everything the configuration for the cluster and stuff like that, it's all YAML files that we also, of course, store in Git repositories for to keep tracks of revisions. Currently, it's running. The Git repositories are not available. We are not sure whether we can. It's sensitive to publish them or not. We are still learning all the stuff, so we prefer to keep that behind the firewall. And if it makes sense to open it, then we'll definitely do it. You had a question?
Yeah, in terms of people, was it difficult for your team to learn the new tools and to change the habits?
Was it difficult to learn new tools? Yeah, Kubernetes is quite a beast. A lot of concepts that you need to learn first. But while I like to compare it to OSGI, when you get the whole picture, it's amazing. The concepts are orthogonal and combine all together to create a whole, very coherent, very cohesive, and it's really impressive. Jenkins Enterprise is actually much easier to understand and to learn. The Operation Center is really just a Jenkins with a couple of new concepts. For Kubernetes, yeah, especially for the setup, but like every new technology. Any other question? Yeah.
How do you make the transition between the old and new infrastructure, because it's still running at this time?
Yeah.
We've seen nothing change, and you mentioned that it's already running at the same physical machines.
No, it's so it's not running on the same physical machine. We didn't buy new hardware. We had some servers which have been decommissioned previously that we have reinstalled. We also have a couple, again, a dozen of machines on which run some VMs, for instance, for the website, the EclipseCon website and stuff like that. And we move some VM to some other machines to free some space to do the first setup, to do the bootstrap. So the goal, the migration path is we will migrate instances machine by machine. So let's say the HIPP1 machine, we migrate all the instances to the new cluster. Then we will deprovision the HIPP1 machine, integrate it into the cluster. So the cluster will grow, and we will do that with the second machine, and so on and so on. Yeah?
So how many projects have taken advantage of the new infrastructure?
So far, none. The setup has been finished last week, and we are just starting to create new instances on that.
I think they have CDT to try that.
Yeah. No more question? Okay, so just a quick recap. We are using Kubernetes and Jenkins Enterprise. I guess you got this one for better scalability and better resilience. And for projects, if you're a committer or project lead, expect little to no disruption so far. Thank you, everyone. Please don't forget to evaluate the talks, -1, 0, or +1, especially if you want to put +1, just vote. And if you want to know more about Kubernetes, I have another talk in Cassiopeia, the theater, right after this one, so now, or in 10 minutes. And I hope you will enjoy the remaining of the conference. Thank you.